there once again. My name is Graphics. Today we want to look at block diagram in parallel. Now we have a new element that is being introduced into this picture, and that is this element. We'll call this element the summer, or we'll call it the error detector, right? And we'll also call it the summing element. So what does this do? It represents the dynamic summation of two or more signals. It's used for what? Adding two or more signals together. In this case here now, we have how many signals connected to it? We have 1, 2, 3. 3 signals. So without the summer, this cannot really be achieved. So the summer or the error detector is used to add two or more signals to give us what? Our resultant signal. So the resultant signal will be the output. Are we together now? Now another new introduction here that we are putting here is what we call it the takeoff point. You see this point, it looks like a junction. In terms of electrical engineering science, we call it more like a node. But in this case here now, we call it the takeoff point. Right? This is the point where the signal branches out and goes concurrently into other blocks. The signal will travel out. From here, when the input signal comes in, it travels out, it comes here, right? It comes here, and it comes here, right? It is due to the help of this takeoff point, that is why they are all distributed into each of these transfer function here. So we have transfer function 1, 2, and 3. Now I can say in this point, we also call it the input signal Rx. Also in this point we call it input signal. Also in this point we call it input signal. That is what this takeoff point has done. Now what we'll do here is this. We are going to say that let the point, one of the inputs coming to the summer should be A. Another one going in here should be what? B. Another one going in here should be what? C. But I would not like to use C so that we will not get confused with this CS we have here. So I'm going to use a function of what? Let me say D. Is that okay? So we'll start by moving how we are going to move. So for A, just like we did in our earlier video, we say that let A be equals to G1 Rx, that is the transfer function 1 multiplied by what? The input signal Rx. We call it equation 1. Similarly, we say B will be equals to what? G2 Rx. Right? That means the transfer function 2 multiplied by the input signal. That is what? My equation 2. Now, if you look at D, it says D should be equals to G3 Rx. So here the transfer function 3 equals to what? Multiplied by what? The Rx. We call it what? Equation what? Equation 3. Now, let's now come. The total function that will be here will be what? The addition of these 3, because they are all plus plus. How would I mean? Now let's see. So we say that the CS here, the output signal, will now be equals to what? A plus B plus C. So it will be A plus B plus what? Plus D. A plus this A plus B plus D. As mean there's a minus here, it will be A minus B, right? Plus D. As mean there's a minus in these two places, it will be A minus B minus D. So it is very, very, very important function here, right? So we should know that the polarity plays an important role when it talks about transfer function. When you talk about signals, polarity plays an important role. So I'm going to say that this is what? Equation what? Equation 4. Now let's move forward. Now we are moving in this manner from the lowest to from the highest to the lowest. So let's start from CS. So we say that the output signal is equals to A, right? But what is A? A is what? Transfer function 1 will have RS, that is the input signal, plus B. What is B? B is what? Transfer function 2 plus what? Times the what? The output signal. Plus, what is D? D is what? Transfer function 3 times what? The output signal. We're inputting our value here, right? So what I do here, I'll say substitute A, B, and D into equation 4. That's what I just did here now. So from here, this will now be the CS, the output signal, equals to what is common to everything. We have our input signal into bracket the G1, right, plus the transfer function 2 plus transfer function 3 is what we have here, because you see the input signal times this will give you, that is input signal times transfer function 1 give you this times this, RS times G1 give you G1 RS, RS times G2 give you G2 RS, RS times G3 give you G3 RS, right? Now we will now divide it by the input. So we say that the transfer function will give us the output signal over what? The input signal. So in doing that, we say that dividing both sides by the input signal RS. So we have CS over RX is equals to RX into bracket G1 plus G2 plus G3, right? Everything divided by what? RX. Now from here we say that the RX will equate RX. So we say our transfer function for a parallel connection, for a block diagram in parallel, will give us the addition of all the transfer function. So G1, G2, and what? G3. So this is how to calculate block diagram in parallel. So if you found this video helpful, please don't forget to click on the subscribe button and watch out for the next video.